From the previous step, we embedded the bits of the message randomly with the pseudo-random generator to add a layer of confidentiality to the message, but it's not enough. We have to satisfy other security principles to make the app more secure and robust. So we'll add extra layers of security to provide integrity and authenticity to the message. This is done by encrypting the message itself before embedding it. The encryption process is done in two stages. The first is formatting the message, then encrypting the message. After that, we embed the encrypted message in the image randomly as discussed before. In the formatting stage, we append the chat message itself with the name and the IP of the sender, as well as the name and the IP of the receiver. Also, we add an extra bit to switch between the private and public message feature, whether the message is broadcasted to everyone or privately sent to a specific user. The next step is to encrypt the formatted message from the previous step. We first generate a signature using the DSE algorithm with the private key of the sender. This sign is then concatenated with the formatted message and the resulted string is encrypted with the AES algorithm with a symmetric key shared between the users. Now to secure the login process itself, we use the same techniques used before to encrypt the login process. So we concatenate the IP, name, and the public key of the sender in one message. Note that this public key sent here is the one used by the receiver to decrypt the signature. After that, we first generate a signature of the string as before, and then concatenate the string with the signature and encrypt them with the AES algorithm. Finally, the resulted string is embedded randomly in the image as discussed before. We use in the login process the UDP protocol to broadcast the login information to the other users. But in exchanging the encrypted message, we use the TCP protocol because it is more reliable with larger data. Finally, with these extra layers of security, we have achieved confidentiality by randomly embedding the message in the image. Also by encrypting the sent message with the AES algorithm using a symmetric key. This way only the users of the application are the ones able to decrypt the message. We have also achieved authenticity and non-repudiation by using the DSA algorithm with the private key of the sender. So now only the public key of the sender can decrypt this signature. Also from the signature, we compare it with the digest of the message to ensure that the message is not modified, and this way we achieve integrity. The same principles also apply in the login process, in which we use the signature and the symmetric encryption.